Trying a new mic here because I'm tired of wearing the headphones here. Oh, so it's weird. They're like noise canceling, but like the noise canceling just like messes with me. So can you give me a thumbs up or something in the chat that you can hear my audio? Like, is this okay? Do you have any audio? All right, thumbs up. Thank you. All right, I think this will be nice. I got it's like a nice fancy mic, you know. Might as well use it. Of course, then if the kids come in the background, like you might get some distracting kids in the background. So today, this is our last. It's hard to believe, but it's our last official time when we're live. I have the exam all ready to post. I think if I go to the news tool, I think it's already programmed to pop up. Yeah, it's going to pop up tomorrow at 8 a.m. You should have a formula sheet for that. So make sure you have a good formula sheet with all of the hypothesis test criteria and how to make the decision, some of those wordings there. So have a good formula sheet. And then I think that's it. Yeah, I'm gonna, starting at 8 a.m. also the D2L content from Unit 4 will be locked out. So you'll only have access to StatCrunch. You'll still be able to get to the Dropbox, of course, and submit that to the Dropbox. So that is it. Today is just gonna be like a review day. I think I should share my other screen so that I'm not like looking back and forth. Hold on. New share, let's share this screen. Share. Do this one instead. Okay, kind of move some stuff around here. Cool, all right. So since this is our last class, I need to have, if I put the chat up here, I don't know if you can see that. I'm just gonna put it up in the corner. I don't know if it shows in the screen share too. So I thought we could just like focus on questions that you had. We have a lot of good resources. We have each, I don't know if you've been checking these, but the practice where we have the quiz each week, I post solutions to those as well. They pop up Saturday morning right after the quiz. So I've got those practice solutions. Those are there. I need to make a note for myself. I need to get the homework grades. I realized I haven't copied those over, so I'll get those grades over. Otherwise, we should have all of our grades finalized now. The only thing left is this Unit 4 exam. So I have the practice from those quizzes, weekly practice. I have the extra review. I think I talked about this last Wednesday. This is about kind of choosing which test you should do, which is super important. So I have that there and the solutions. We can talk about that today if you want. And then as usual, we have a practice exam and the solutions to the practice exam are posted. So I don't know if anyone has anything specific that they would like to go over, or if you have a specific topic that you would like to review. I will take requests. Yeah, let's take a look here. Number 3 on the practice exam. Okay, so Rachel, was that from last week, Rachel? These are the second semester I've used these, and they should be good. Oh, for the practice exam. Okay, practice exam. Thank you for clarifying. Okay, practice exam. Let's take a look here. So we have a local politician. I think I posted, oops, should be like a practice exam for Dataset. So let's see if we can get signed in here. Take a look at number 1. Oh, I'm never gonna find it. Too many data sets. That's exam 4 data. Practice exam 4 data. All right, so we have prison time. Local politician running for re-election claims that the mean is less than the required 5 years. To test his claim, he has prison official a random sample of 30 car thieves shown to the right. And now to test the politician's claim. Okay, so let's take a look here. We have T-stat, one sample. We do have data, one sample with data, prison time, and our hypothesis is that the mean is 5, and our alternative is that it is less than 5. Correct. The local politician claims the mean is less than the required 5 years. Okay, that looks good. Let's hit compute. Okay, so I don't know. I don't know where your. Do you remember what you did, Rachel? I don't know. I should put up the answers and not the practice exam. Yeah, sometimes it's like, well, this is what I got. I don't remember exactly what I did. It could have been maybe you did a Z. That's not going to be, that's usually not that different though. Like a Z, which we don't really do Z's. So that's not going to be that different. Yeah, that's pretty similar. So yeah, I don't know where that test, just did the wrong test somehow, just did the wrong test. So it looks like we got it here. Yeah. Yep, no problem. And then Brittany is asking about number 3. The table below also available in the data, a summary of responses. Beginning algebra students. Yeah, I did this little project with my beginning algebra students, kind of how they feel about math. And this one was I enjoy math. And so I had a few variables, but one of them was their gender and then their response. And so we're trying to determine if there's enough evidence at the 5% level of significance to support the claim that a student's gender and his or her response to the statement, I enjoy math, are related. So this is a test for independence, chi-squared test for independence. So here we have our data. So we're going to do a stat tables contingency. That's where you do the test for independence, is the contingency table. If I were you, I might make some notes of these. So if you're going to do a test for independence, stats, tables, contingency. We don't have the data this time though, we just have the summary. So with summary, the columns are under the agree, neutral, disagree. So we'll hold down the shift. And then the categories, the row labels are gender. And I'm just gonna hit compute because here in the default setting is to do a chi-squared test for independence hypothesis test. There we go. And there's our chi-squared, p-value really high. So it's like, well, seems like they're pretty evenly distributed. Like there's no, it doesn't, remember the null hypothesis on this test is always that they're independent. So we don't have any evidence here to reject that. So not enough evidence. It's reasonable to say they're pretty independent, which is good. You know, this is real data from a real survey that I did. And there's all these studies about gender and how it's related to math and abilities and all these things. And so at least for that little sample, it wasn't a huge sample, it's just 2 sections of my students. At least for that little sample, didn't seem to be a difference based on the student's gender. Oh, it's not in the My Groups section. Okay, well, let's see here. Let's do data, properties, and I can make sure it's shared. Oh, it wasn't shared with you. That would have been good. Okay, if you hit refresh now, Nick, it should be there. I was making everybody type all those in, my bad. So if you hit refresh and look at that, yep, no worries, no worries. Yeah, it's frustrating. When I make a new group every semester, I like check which data sets I want to add, and like sometimes I forget which ones to add, so I have to manually go in later. So that's good. Good. Brittany, did you figure out what happened on that one? Do you understand how to do number 3 now? Gotcha. What can happen, what some students do is they put in the totals also. And then what StatCrunch thinks is it thinks that's another category. Total is another category, and this is another category. So you only want the counts in StatCrunch. You just want the counts. You don't want the totals if you have to put in a summary table like this. So that was not clear directions there. Plus, I'll try to give you the data so you already have it. Okay. I think that was it so far for the questions. We had Rachel and Brittany. Okay, so what other requests? And we can do practice exam or other stuff too. Any other requests, specific requests today? So from the box plot, a lot of these, it's about just basically using our, like say this example number 4. We can't really reject the null hypothesis, but we could kind of like estimate, well, based on this box plot, could we reject the null hypothesis? And it depends on the test. So it's really important. The reason why I'm asking those questions, and I think the ones you're thinking of are at the very end, if I remember correctly, these. I want you to understand what those tests are saying. So like, for example, that number 4, I'm gonna try to show, I can't, maybe if I download this file, kind of wasting a bunch of screen space here. So I want to show the graph and the null hypothesis. So for this test where you're comparing multiple means, the null hypothesis is that all the means are the same. We're talking about class size. So we're talking about the average class size is the same for all 4 types of schools. And so from the box plot, I would look and I would say, well, the box plot doesn't show the mean, but it does show the median, which is kind of like the mean. That's the middle bar here is the median. So what I'm looking is, are the means, or the medians, I should say, is what I'm looking at, are they all pretty much lined up? And I can see here, looks like from the box plot that the average is smaller than here. So just based only on the box plot, I would guess that the alternative is going to be, there's going to be evidence for the alternative. So I would guess that we would reject the null hypothesis here simply because this mean is different from all the others, from the other 3. And that's what the test is. They're all the same, or at least one is different. So that's what I would do here. I would just guess that. For the last ones here, again, we're just trying to guess based on this. So this one is a test about the standard deviations. That's the spread. So I'm looking on the box plot, I'm saying, all right, are the spreads similar? And so if I looked over here, I'd say, well, they're pretty similar. Like the blue box is pretty much the same width. It's a little bit different, but pretty similar width there, pretty similar width. The for-profit tends to be, looks a little bit wider, but this is the middle 50%. The middle 50% width is almost the same. And the left tail is almost the same. There just are there's some private for-profit schools that have like that 100% completion rate. I don't know who that is. So a little bit of grade inflation happening there. So, but we're talking about the spread. So that's what I would say here is they're pretty similarly spread out. So I would not reject the null. The last one is about the mean difference. So we're looking at the change in percent proficient in 1 year versus another. So we do a difference between the 2 years. And then we look at the mean difference. The null hypothesis is that the average difference is 0. Well, if I look at my box here, the median appears to be exactly at 0. The middle 50% are on both sides of 0, really condensed. So maybe, what is that? Negative, like here it'd be -10, like -4 or -3 to +3. Like it's really close to 0. It's on both sides of 0. So I would say, it seems like the difference is not different from 0. So I would not reject the null hypothesis on that. Again, we're not actually making the decision, but it's kind of like what we would guess based on the box plot. So the key there's no one way to do this. The key there is you really have to understand what that null hypothesis is asking you and what the box plot is telling you. That's the challenge on these. Does that help on that one, Brittany? Okay. So that's much more a conceptual question. You can learn the procedures, learn how to do the tests and all that. But it's another thing altogether to kind of just understand exactly what's happening. Like, what about this one? This is the, where was that? Education data. So like, for example, let's do this. We're looking at standard deviations. Oh, actually, let's do one where we would reject. I'm trying to find one where we would reject. That's a proportion, mean difference. These are proportions. There's another mean one. I'm not finding a good example to kind of guess. Let's do number 9 the way we probably should have done. Are the standard deviations the same? Are the standard deviations the same? This is of average class size, district equals large, district equals small. So we're going to go stat, T-stats 2 sample with data. We have 2 samples. We're looking at average class size where, what was it? District size equals large. And then average class size where district size equals small. And the null hypothesis is that they're equal. Let's do a not equal to. Let's do a not equal to. And then we compute. So there's our test. That's what we should have done. We should have done a not equal to. But then, now let's look at the box plot. Let's look at the box plot. We're going to do a box plot of average class size, and we're going to group by district size. Okay. We're going to do horizontally. I'm going to turn off the fences and just hit compute here. So I have medium in here as well. So if we're looking at the means, the average class size of large versus small, much higher for large, but that's not what we're asking about. We're asking about, we are asking about means. Oh, I did the wrong one. It's standard deviation. Okay, so the means definitely reject. See, this is why you have to make sure you're doing the right test. The question was about standard deviations, and I was doing a mean comparison, mu large versus mu small. So the mean for a large, I wonder if that's what I meant. See, if you look at the standard deviation, the small one appears to be more spread out. At least the blue box appears to be more spread out than the large one. I wonder if we show outliers. There's some outliers. There's a lot of outliers on the large one. But still, this appears to be more spread out. So the mean is definitely larger here, but that's not what the test is. The small one appears to be more spread out than the large one. It appears to be. We could do that. That's the test that we were actually supposed to do. But that actually, it's interesting. I don't know why I asked, does the large one appear to be more than the small? I don't know. It's interesting. So that would be a variance stats, 2 sample with data. And this is where we would do the average class size where district equals large. That was our population 1. Average class size where district equals small. And we were doing sigma 1 was greater than sigma 2. So this would be more than 1. And that's where we got that very small F statistic and a very large p-value. Now I'm wondering, what if we did not equal to? Just did a 2-tailed. Yeah, see, if we do a not equal to, then you get a less than. The reason is, this is kind of hard to draw on here, but the reason is one standard deviation, the actual standard deviations, I feel like I'm making it more confusing here, but so the actual standard deviation for large is less than the standard deviation for small. So if you're doing a hypothesis test that the standard deviation for large is more than the standard deviation for small, you're going to get a p-value that's not small, because the standard deviation for large districts is not greater than the standard deviation for small districts. So that's why it was a little confusing the way that one was phrased. So I probably should have done a not equal to, or maybe done the other direction, standard deviation of large. But this happens sometimes when you do research, is you think something is true, you collect some data, And it turns out it's not that way at all. So that's why this one feels a little weird to me to get a p-value that's almost 1. And the reason is because we went the wrong direction here. But that's what the question asked. Suppose we wonder if the class sizes at large districts have more variability than the class sizes at small districts. And we could really see the answer to that right here and right here. Right? The standard deviation at large districts is actually less than the standard deviation at small districts. That's definitely not true. And then if you look at the spreads, this is to Brittany's original question, the box is much more condensed for large than it is for small. So that would also say, no, it doesn't look like the standard deviation for large is more than the standard deviation for small. It looks like it's the other way around. So long answer to your question, Brittany. I hope that helps kind of clarify how to do those. All right, this is good discussion so far. Any other specific requests, either from the practice exam or elsewhere? The other thought I had to use our time, if you want some review, is to work on this last review. Now, this is something we would normally do in class, right? And I would give you some time to do this. Unfortunately, I used to have, I don't know if you remember doing the polls. Unfortunately, I can't do the polls anymore because my Zoom membership changed and I just have like the basic membership now. So I thought we could look at these. These are a bunch of different hypothesis tests. And the challenge, I guess, is really just to get the null hypothesis. Is the null hypothesis, is this a 1 sample mean, 2 sample means, a mean difference? Is it a 1 sample proportion, 2 sample proportion? Is it 1 sample standard deviation or 2 sample standard deviation like we just did? Is it a goodness of fit test? Is it a chi-square test for independence? Is it a ANOVA test? So we have all these tests. And sometimes I see students, understandably, get a little confused because there's a lot of them. And you get to the final and you start doing the wrong test. Your work makes no sense. You don't understand it, but you're just kind of following some steps you wrote down and hoping it makes sense. And it ends up looking very clearly like you don't understand what you're doing. And so a big part of that is making sure we get the right test, that we're doing the right test. So let's do, I don't think I have a good way for us to answer like not all at once. Why don't you do this? Do you know how, can you see this? I'll put the chat off to the side. Do you see in the chat that you can send a private message just to someone? So I'm gonna put the chat off to the side so it's not shared. Why don't you do a private message to me and I'll give you it shouldn't take long. It should be like 30 seconds. Let's read this first question together. We'll try to do this for a few of them. We're gonna try to look at what is this about? What is this test about? So we have monthly incomes of college graduates. They have a standard deviation of 650. It is believed that the standard deviation of monthly incomes of non-college graduates is higher than that. So a sample of 71 non-college graduates are randomly selected and found to have a standard deviation of 950. Test the claim that non-college graduates have a higher standard deviation. Use alpha equal 0.05. So 1 sample mean, 1 sample proportion, 1 sample standard deviation, or 2 sample mean, 2 sample proportion, 2 sample standard deviation, or goodness of fit. I need to write all these down. Oh, let's make it easy. Let's make it easy. Let's do, then you don't have to type as much. So we'll just number 1 sample. My keyboard is where's my keyboard? 1 sample mean, 1 sample proportion, 1 sample standard deviation or variance, 2 sample mean, I guess we missed mean difference, 2 sample proportion, 2 sample standard deviation or variance, and then we have goodness of fit, test for independence, and then ANOVA. Am I missing any? I think that's it. I think that's the list, right? I think that's it. So why don't you send me a quick message, 1 through 10. Which one do you think number 1 is? 1 through 10. I have 5 threes, 6 threes. Yes, everybody's got it. This would be cool if we had a poll, right? Wouldn't we just do a poll and pick which one? If I teach you this again in the fall, actually I am teaching it again in the fall. I might actually have to pay for the next level of Zoom. It's cool. It'd be cool to do the polls. Yes, you are correct. It is 3. It is a 1 sample standard deviation. Oops, let's do this. Bloop and bloop. Okay, next, Tennis Pro. Oh wait, we're here. There, we can zoom in. Oh, this isn't the right one. Sorry. I don't know what size screen you're looking at, so I want to try to make it bigger. Tennis Pro, strings rackets at the tension requested by the customer. A customer made a claim that the Pro Shop consistently strings rackets at a lower tension on average than requested. Supports this claim, the customer asked the Pro Shop to string 15 new rackets upon the customer measured the tension and calculated the following summary statistics. Find the p-value for this test. So recently a customer made a claim, there's the claim, that the Pro Shop consistently strings rackets at lower tensions on average than requested. Okay, what do you think? Which test do we think for this one? Gabby's got it. Daniel's got it. Rachel, good thought. I guess that could make sense. I think Brittany, I think you're on that could make sense here. Let's talk about it after we give people a couple more minutes or a couple more seconds here. Anybody else? There's 2 different answers so far. I think it's one of them, but I can see the argument for the other. No one else is sure yet. Okay, I'm seeing 1s and 5s. So I would probably say 1, but I see the argument for 5. So because the claim here, of course, is that they're consistently lower than requested. So it's kind of like you're comparing 2 different things, the requested and the actual. And so are you looking for a mean difference? So that's plausible to me. There's not really enough information. But actually, if you look at this here, there is enough information. To support this claim, the customer asked the Pro Shop to string 15 new rackets at 58 PSI. That's important. I was reading too quickly earlier. So what this is, this 58 PSI was the average that was requested. And then we have a sample average that we're comparing to that. So this is actually number 1. This is a 1 sample mean, because we're not comparing 2 different samples and it's 1 sample lower than the other sample. Yeah, okay, so good thought. Both are plausible here, but because we're not given a sample of 58, we're just asked, no, this is the mean I want. All right, next, we got 2 groups of students, no, 1 group of students. They're taking a test preparation course and then retaking the SAT. So they get a score on the SAT, they take this class, they take the score again. And the test, the claim that the test preparation had no effect on their scores. So basically we're wondering, does the test prep class improve their scores, right? And that's what they're supposed to do. Kind of eyeballing it, it looks like they mostly go up. Don't know if it's statistically significant or not. So what do we think about this one? What kind of test is this one? If you have good notes, the before and after is kind of a dead giveaway on this one. So I have Rachel and Gabby, you are correct. Those are correct. Anybody else still thinking? Daniel's got it. You're correct. Yep. What you want to do, the reason why we're doing this now is you don't want to be working on the exam, burning through a bunch of time figuring out what test is this, right? You want to be able to jump right in. So Rachel, Gabby, Daniel, Alyssa, that's correct. Yep, you have it also. The key is the before and after. And if test scores improved, then there should be a positive difference. Like the difference, if you define after minus before, there should be a positive difference then. So this is about a mean difference. It's not about comparing two means because the samples are not independent. They're paired. It's the same student before and after. So that's why this is a mean difference. That's what this one would be. If it's a mean difference, we're looking at test the claim that the test preparation had no effect on their scores. And so we would be subtracting these. StatCrunch would do all that. We would put, at least I would put after minus before. I would put after as population 1, before as population 2. You could do it either way, but if you did before minus after, your alternative claim would be that the mean difference is negative because you think the after is bigger. All right, any questions so far about the first three? Just picking the test, that's all we're doing. Any questions so far? Nick asked a good question just privately about the timing. In the future, when I do this class in the fall, I probably will do that and time the test. But for us this semester, I just didn't want to add that extra stress with all this other stuff going on right now. So it will not, and it'll just be posted at 8 a.m. And you'll have a day and a half, whatever, to work on it. So, but in the future, I'll probably have it be in like a D2L quiz, and it'll be timed. And so you open the quiz and then you'll see the questions and you'll kind of upload to the Dropbox separately. But this one will not be, not be timed. So it'll just be posted to a news post. I think I mentioned earlier. Whoops. So there's a window of when you can start. So it'll be, you don't see this yet, but if I go to the news tool, you can see my post that's getting ready here. So it'll pop up at 8 a.m. tomorrow, and then it's you just have until you can take as long as you want, and the Dropbox is due to the Dropbox by 2. Well, we have a lot of stuff here. Does it show the deadline here? It should. 2 p.m. 2 p.m. on Wednesday. So you have all day tomorrow, and then most of the day on Wednesday. And there's no. It's just I'm just going to post the PDF, so there's no password on it or anything. So no restrictions there. All right, let's go. Let's move on here. We have business college. Computing Center wants to determine the proportion of business students who have personal computers at home. If the proportion exceeds 30%, then the lab will scale back a proposal. This is so old. This problem is so old. Oh my gosh, I'm so embarrassed. What? There's a college and only 30% of their students have a personal computer at home? When did this question written? 1990? I'm embarrassed. Oh, okay. So I have a couple people answering me. I'll give you another like 10 seconds. What test is this? What do you think? What test is this? Oh, that's so funny. Can tell Professor Kernler has not updated his problems in a while. This is only going to get worse the older I get too. Like I'm only in my 40s now. I have like 20 years of this left. What's going to happen 20 years from now if I don't change this? People are going to be like, what's a computer? Because it's going to be something 20 years from now. Geez, it's going to be totally different. All right, so Alyssa, Rachel, Brittany, and Gabby all have it. That's all correct. Anybody else want to give an answer before I tell you? Daniel, that's right too. Yeah, so this one is, this is number 2, that's correct. This is a 1 sample proportion. So we have this 30% as our comparison value, and we're gonna do a test, I think, if the proportion exceeds 30%. So we're gonna do, an alternative is P greater than 30%. That's what we're gonna do here. So this is a 1 sample proportion. All right, next one. Manufacturer claims that the mean lifetime of fluorescent bulbs is 1,050. A homeowner selects 40 bulbs and finds the mean lifetime to be 1,030 with a standard deviation of 80 hours. Test the manufacturer's claim. This is that, like, this is like your super weird nerdy uncle who like literally screws in a light bulb and turns it on and like measures, records the data for exactly how long that light bulb has been on. That's what this is saying. You had 40 bulbs and you like collected data on how many hours each light bulb was on. Oh, I'm in a goofy mood today. All right, Alyssa, that's correct. Anybody else know? Let's see, Brittany's got it. Daniel, Rachel, nope, it's a simpler one than that, actually. That one is if you have multiple, like more than 2 means that you're comparing. Gabby's correct. Yep. Yeah, this one is a single mean. This 1,050 is what we're comparing to. So that's our comparison value. And then we just have a single sample, 40 bulbs. Here's the mean. Here's the standard deviation. This is just a 1 sample mean, just a 1 sample mean. Okay, so now we have a number 6, we have a pain reliever. The standard deviation must not, so you don't want, it has this much pain reliever in it, you don't want it to vary too much. So we can't have the standard deviation exceed 2 milligrams. So quality control manager, this makes more sense, this person's profession is to quality control, selects a random sample of 30 tablets, finds that the standard deviation is 2.4 milligrams. We're going to assume that the active ingredient is normally distributed. I don't know if you remember that test. That's one of the requirements for this particular test, is that the variable must be normally distributed. We're going to test the claim that the standard deviation of the amount of active ingredient is greater than 2 milligrams. So this one's pretty easy. There's really only 2 options. What do you think for this one? Yep. Looks good. Everybody's got it so far. Anybody else want to answer? Nobody else wants to answer. It's okay. That looks good. So the key here is you can see the standard deviation. It even says test the claim that the standard deviation, singular, of the amount of active ingredient is greater than 2 milligrams. So this is a 1 sample standard deviation question. Cool. All right. Next one. Survey claims 9 out of 10 doctors recommend brand Z for their patients. To test this claim against the alternative that the actual proportion of doctors who recommend brand Z is less than 90%, a random sample of 100 doctors results in 84 who indicate they recommend brand Z. Find the test statistic for this test. So what test is this? Interesting. It's a little subtle. Brittany and Gabby, that is correct. Daniel, also correct. Yep. All right, I think everyone's got it. Alyssa, that's right. So it's a little subtle because you do have 2 proportions you're given, kind of. You know, you have the 90% and the 84 out of 100, but this isn't actually just 10 doctors. This is like, you know, you see in the ads, oh, 9 out of 10 doctors. Right? They didn't actually just ask 10 doctors. They asked a bunch of doctors, and the 9 out of 10 is just like for lay people to understand that it's 90%. So this, even though there's that 90%, that's just your comparison value. You only have 1 sample. This is a single sample proportion. That's right. All right, what about number 8? This is kind of fun. Smoking There's a lot of smoking teachers. I don't think the results would be that high now. What do you think? We have elementary teachers, 15 out of 100 elementary teachers, 36. I don't think the proportion is that high, but maybe it is. It's like in my department, it's there are 2 full-time faculty out of 14. Well, maybe that is plausible. All right, I'm seeing some answers so far. They are all correct so far. Yes, still correct. I think everybody's got it here. We're clearly proportions. It's the out of in a sample of 115. So it's, it says the word is the proportion greater than the proportion. So we're comparing 2 proportions here. So this is a 2 sample proportion. Number 6 is correct. Awesome, we're doing great. All right. Trucking firm suspects that the mean lifetime of a certain tire it uses is less than 38,000 miles. To check the claim, they get 54 of those tires. They get a mean lifetime of blah, 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 blah. So the claim, they suspect that the mean lifetime of a certain tire is less than 38,000. So what test do we think for this one? Yep, looks good. I'm seeing 1s all around, right? It says mean, and it's a random sample, right? So it's a 1 sample mean. Awesome. Moving on. 36% of adults in a certain country were morbidly obese. Health practitioner suspects the percentage has changed since then, so she collects some data. So what do we think? We're testing whether the percent has changed since 2000. And she has some data from her random sample. What test does this one look like? Getting some repeats now. Yeah, looks good so far, Brittany and Gabby. That is correct. All right, so this one should be a 2. So the percent is a dead giveaway, that you have a percent. So you know this is about some kind of percent, which is proportions or percents. And then the key here is she has a random sample of, and then it says here a health practitioner suspects that the percent has changed. And then she has a random sample of 1,042 and finds that 393 are morbidly obese. So that's 393 out of 1,042. Again, all hints that this is about a proportion. And we just have a single sample here, just a single sample of these 1,042 adults. So this is a 1 sample proportion. The next one is, how many more do we have here? I want to get to some that are more interesting. We're going to work backwards. We're going to see if these are some of the newer ones. Let's see. Statistics professor at all women's college determined that the standard deviation of women's randomly select male students by all male. Okay. All right. I don't think we've done this one. Maybe we have done this one. I can't remember. So we have the standard deviation of the women's height at their college is 2.5 inches. And then we have 41 male students from a nearby all-male college and found the standard deviation to be 2.9 inches. The claim is that the standard deviation of male heights is greater than 2.5 inches. Yeah, I think this one's a little sneaky. No one actually has it yet. It's sneaky. Not only is it later in the document, so you think it's one of the later ones, it's also worded a little sneaky here. So it is, no one who has it, no one who's typed an answer yet has it correct. Alyssa got it. Yeah, it feels like you're comparing men and women. Men and women. So the difference is we only have data from 1 sample. We have these 41 male students and we have their sample standard deviation is 2.9 inches. The claim is that the standard deviation of male heights is greater than 2.5 inches. It's kind of a weird test. Normally you would collect 2 different samples, one sample of women, one sample of men, and then you would compare the standard deviations between the 2. So 7, if I were doing this experiment or this study, 7 makes more sense to design it that way. But the way that it's phrased, the 2.5 is simply a comparison value, and we are simply comparing our 1 sample to that value. So it's actually, the way that it's worded is a 3. That's awkward, very awkward. Let's see, 16, we gotta find some that are interesting here. What's 15, there's a lot of writing here. There's gotta be more interesting. You see 16 is bus company claims the mean wait time is less than 5 minutes. They have a random sample of 20 wait times with a mean of this. Test the bus's claim. See, this is the mean, and you have this sample data from a 1 sample. So it's another mean one. That's gonna be another number 1 though. So let's look at 15. 65 female students were randomly selected. It's found that their mean monthly income was $641 with a standard deviation of $121.50. 75 male students were also randomly selected, and their mean monthly income was found to be $683 with a standard deviation of $168.70. Test the claim that male students have a higher monthly income than female students. All right, what do we think about this one? Everyone is right so far. Oh, no proportions though, no proportions. These are not proportions. So Alyssa is right, Daniel right, Gabby is correct also. Oh, good thought, Brittany. So this one is clearly about comparing 2 means, but it's going to be 2 independent means. It's number 4, it's 2 sample means. In order to use number 5, they have to be paired. This one has a red flag because you have 65 female students and then 75 male students. So they can't be paired anyhow because they're not the same number. But even if they were the same number, it's like 2 different random samples, 65 random female students, 75 random male students. So this is a 2 sample mean here because they're not paired. So the only way you can do number 5 is if they're paired somehow. Most commonly, it's like a before and after. That's a common way to pair them. Okay, this is another proportion one. Another proportion. So we always have like 1 minute left here. None of these are, there's no ANOVAs here or test for independence or good. I think those are easier to identify, honestly. Those are just easier to identify. I think that's why I didn't put those on here. Let's look at 12, this last one. 61, this is another 61. Oh, this is male and female students again. It's the standard deviation of their monthly income. Test to claim that variance of monthly incomes is higher for male students than it is for female students. So that would be that would be number 7. 2 sample standard deviation or variance. Oh man, I guess that's it. Man, it feels so anticlimactic. What a crazy semester. There's more stuff for you to review here. Take your time. Again, the exam will be posted tomorrow morning. I wish I could, like, in person, like, thank everybody for all your hard work this semester. Some people I know are not able to come. You know, we don't have a lot of people. We haven't had a lot of people for a while. People are busy, got other things going on, and I don't know, it's been a challenge, but I've just been super impressed with how people are continuing and keep doing the work and submitting quizzes and doing the homework. And the last test went really well. I'm kind of hoping that the same for this one, that people will continue to do as well. And so I just wanted to say that I've been super impressed with how everybody's continued through here, even though, like, I hate teaching like this and, like, no one's in front of me and I'm making eye contact by looking at a little dot on a camera that's sitting on my desk. So, like, it sucks, but I think we're really making the best of it, and I'm really impressed with how everybody's done. So your tests will be the first that are submitted. The rest of my classes, they're going to be submitting theirs a little bit later. So I will hopefully get started grading them right away tomorrow, Wednesday afternoon. That's my hope, to kind of get that first class out of the way. So keep your eye on D2L. It should be open. I should make sure it should be open for another couple weeks. I always like to put like the end of May as the deadline. All right, let me extend that. So it'll be open until the end of May. But keep your eye on things. I'll put a news post once final grades are up. And yeah, if you have any questions about anything that's missing or any homework questions or questions for this unit, feel free to just let me know. I've got a busy afternoon today, but I can, I'll be able to check my email later today for sure and get back to you. So I guess that is it. Any last questions or comments before we call it a day? All right. The last request I have then, if you haven't, did I post? Oh, did I post? I posted the link, right, to the survey. Where did that go? Maybe I emailed it to everybody. All right, I'm going to post a link again. I had a survey that I sent. I must have. Where is it? Because I have some responses. But there's a survey that people have given me some good feedback for how to run the class if we're in this kind of format again in the fall. And so I would love your feedback on that. So I'm going to put a little note to myself there. Oh, maybe I emailed it to everybody. Maybe that's what it was. So I'd love to get your comments on that survey if you haven't commented there. All right, I guess that's it. Thanks for persevering through a tough semester. I've been super impressed. Let's keep it strong. Last test will be posted tomorrow at 8 a.m. That's it, everybody. Signing off.